The robot has been constructed with sensor integration in mind. The sensors include a humidity and temperature sensor, two gas sensors that monitor air quality and flammable gases in the atmosphere. The other sensor that is 10 DOF IMU sensor, which contains a gyroscope, accelerometer, a barometer, and a temperature sensor as well. There is also a Bluetooth module connected for Wi-Fi Bluetooth data transfer to a C# application that has been made. A Raspberry Pi is connected to a night vision camera and transmits live video feed using Wi-Fi over local area network that is powered by an external battery pack, and the servos are also connected and powered by the external LiPo battery. There are a total of 6 ultrasonic sensors that monitor distances around the robot and alert the user and the robot about the collisions that might happen. A battery monitor is also installed on the battery pack to monitor voltage levels of each individual cell to prevent it from over-discharging and potentially causing harm to the LiPo battery. The camera is controlled using a pan-tilt platform that is controlled using 2 servos. The whole system runs on an Arduino Mega 2560 kit, and the USB is powering the Arduino Mega. Everything else is powered off using the LiPo. To connect to the robot, first we have to initiate a connection, an SSH tunnel connection to the Raspberry Pi. We use a program called PuTTY. After logging in, the command is a command is sent to the Raspberry Pi that initiates the camera connection, a connection to the application via client-server based architecture. Once the server is initiated, and the application can be run. In the beginning, the video player connects to the server and displays images all in real time across the local area network wirelessly. We then connect to the serial port that the Arduino Mega is connected to for data transfer. We can connect to wired connection and a Bluetooth connection. We'll start by using a wired connection. Once the data transmission begins, the user is notified and data is visualized using 6 graphs, and also visual representation of the ultrasonic sensors are presented in this diagram. Currently, we'll start talking about the ultrasonic sensors. The values of the ultrasonic sensors depend on the range of the obstacles and the distance it is from the robot. For example, this ultrasonic sensor represents ultrasonic number 5 on the robot. I'll place my hand on it to show you the distance. I have set the collision distance to 30 centimeters. So when it goes closer or below 30, it turns red to alert that there's a collision imminent. Rest of the sensors also work in the same way. Okay. Back to the camera. We can also control the camera using these 4 buttons. which allow for the camera's rotation in the X and Y axis. We can move up, left, right, and we can also center the camera in the original position it was. The camera has a rotation of 180 degrees and is capable of night vision features. The application also displays all the other sensor information, including the air quality sensor, the flammable gas sensor, the temperature sensor, the altitude of the place, ambient light, which can also be tested in real time. If I keep my hand over the light source, you can see a sudden dip in the light intensity. Then I let go of my hand, it goes back up. Also, there's humidity sensor as well. If I blow on it, there should be a rise in the moisture around the sensor. As we can see, the temperature also rises. Okay. The application has a wireless capability of connecting to the robot to a range of up to 50 meters. The camera wireless feed has a range of up to 100 meters. Thank you. Although the project's aims have been met, early tests and future implementation of making the robot work has been implemented. This test that calibrates all the servos and have sweeps all the servos so that the user can know that all the servos work and are configured properly. We can start the mode by pressing S according to the instructions, and this is